For years, machine learning was strictly a digital exercise. Code was written, models were trained, and outputs were generated. But the actual intelligence remained behind screens, disconnected from the physical world. This chart compares specialized robotics with humanoids. Specialized machines excel at repetitive tasks, but require entirely custom factory floors. Now, generative AI is migrating from bits to atoms. Multimodal models allow machines to perceive dynamic environments and imitate human action with precision. This embodied AI allows a machine to operate in spaces designed for humans. Rather than customizing a warehouse for a robot, the robot is now flexible enough to use the stairs, doorways, and tools we already have. The economic scale is massive. With 3 billion people employed worldwide, the global labor market represents a $30 trillion addressable market. By 2050, the U.S. alone could support 63 million humanoids, representing a $3 trillion domestic wage impact. Securing a share of this market requires more than just high-performance code. It requires mapping and supplying an entirely new global manufacturing chain. Navigating a physical room begins with a central computer processing inputs from cameras and microphones to decide on an action. This relies on two types of silicon. Vision semiconductors live at the edge, processing sight in real time, while data center chips run training simulations. Because the robot is constantly retrieving and storing data for on-device computation, memory fabricators are a critical bottleneck. Without high-speed DRAM and NAND storage, the processing loop can't keep up with the physical world. But intelligence only provides the plan. Translating that plan into movement requires a physical architecture that can mirror human biology. The humanoid body is a massive hardware challenge. Depending on the complexity of the hands and the required payload, the bill of materials for a single unit can range from $10,000 to over $300,000. To interact with fragile objects, the robot needs sensory nerves. This is where 6-axis force sensors come in. They provide the high-resolution feedback required for a humanoid robot to grip a piece of fabric without tearing it. These diagrams show the actuators, the robot's muscles. Linear actuators push and pull limbs, while rotary actuators handle joint rotation. Internally, they require precision ball screws to convert motion, strain wave gearing for torque, and rare earth magnets for efficiency. While software can be refined in a virtual environment, these mechanical parts must withstand the constant stress of gravity and friction. The challenge is as much about metallurgy and precision machining as it is about neural networks. The integrators are the firms pulling these components together into a finished working robot. Major automakers and consumer tech companies are moving into the space, using their existing scale to pilot humanoids in their own factories. Automakers have a specific edge here. They already manage massive manufacturing lines and use electronic architectures in their vehicles that are very similar to what a humanoid requires. But the supply chain is heavily concentrated. Currently, 73% of the companies confirmed to be involved in the humanoid value chain are based in Asia. This geographic dominance stems from local supply chains and strong government backing, allowing faster iteration than the West. This grid, the Humanoid 100, shows a multi-tiered industrial ecosystem, following a trajectory similar to the electric vehicle market. As manufacturing scales, component costs are expected to drop by roughly 11% every year, making wide-scale adoption a financial reality. These more affordable units will begin filling labor gaps in sectors with high turnover or dangerous conditions, moving into general logistical work. The convergence of falling hardware costs and advanced embodied AI puts the humanoid in direct competition with the human labor pool. The shift from experimental technology to a core economic driver is a matter of manufacturing scale. Before you go, make sure to check out the Learn by Doing with Steven YouTube channel and find us on other platforms. Don't forget to listen to the Steven Data Talk podcast, available on YouTube Music, Spotify, and various other platforms. Thanks for watching.